It turns out that this reaction was discovered back in 1886 by Hans Heinrich Landau and is still used to this day as a relatively simple method of displaying chemical kinetics for students. It is called the iodine clock reaction because the solutions do not turn color right away, but takes some short amount of time of that is normally measured with a stopwatch. It works by what are known as oxidation-reduction reactions, or transfers of electrons. To begin, we crushed up vitamin C tablets and filtered them into a cup along with our iodine. I then took a second cup and added hydrogen peroxide and a little bit of cornstarch to it before swirling. All of that was left was to add the solutions together and swirl them around and wait. I think part of the reason it takes some time to see a reaction or color change is because of the two competing reactions that are occurring. This graphic was taken from the video listed on the module, and it shows the two competing reactions that happened once the two solutions are mixed. In the first reaction, we see that we have a molecular iodine reacting with vitamin C to produce iodide ion and acidic protons. This is the first oxidation reduction reaction we see as the molecular iodine is getting reduced to iodide and the hydrogen is being oxidized to acidic protons. The next reaction shows uh, the next reaction shown requires that the iodine already be reduced to iodide, and we have hydrogen peroxide reacting with it to actually revert it back into the molecular iodine. In this reaction, iodide is being oxidized to a molecular iodine and the protons are being reduced to form a water molecule. This slide shows ultimately what produces the color change in our reaction. It turns out that at some point, the vitamin C from solution A will run out once the reaction mixtures are mixed. And since we added a lot of extra hydrogen peroxide, we will end up turning a lot of iodide created from the vitamin C back into molecular iodine. This graphic here from the same video shows that iodide and molecular iodine will react to form triiodide, which is what ultimately is going to bind the cornstarch molecules and change the color of the solution. Unfortunately, after trying once and then again, I was still unable to receive the desired result for this clock reaction. I have thought up several reasons why this might not have worked, and I might have a feeling it had to do with the fact that some of my ingredients was dated, and I know at least the hydrogen peroxide was in my medicine cabinet for a while. The first source of error could be from the vitamin C. If I didn't get enough dissolved into solution before filtering, or my filtering process didn't work so well because the solution was still a little cloudy even after filtering. According to the video, if I didn't get all the fillers and substances out of the solution, it could affect my reaction negatively. If there isn't enough vitamin C, not enough iodine will be produced to complex with the iodine that the hydrogen peroxide would reform. I'm certain the cornstarch was doing what it was intended as I purchased it brand new. As I said earlier, the hydrogen peroxide from my cabinet has been there for a while, and it's only 1% as compared to 3%. I added what I thought was a lot extra to compensate for this. But if it's too old, then the hydrogen peroxide may have decomposed a bit I'm assuming, and wouldn't properly reform the iodine. The last thing I can think of would be the fact that maybe I just simply didn't wait long enough. I discarded the first reaction after about 3 minutes and then timed the second reaction up to 5 minutes and still saw no change. Maybe my solutions were too dilute for the reaction to properly take place in a timely fashion.